All right, let's do this. This talk is either going to take about 5 minutes or 5 hours, depending on how many questions you ask and how much you interact with me. I haven't figured this out yet, so let's see how this goes. Welcome, welcome. The original title of this talk was Expression-Based C++ for Better Code, but I just realized that really this applies to basically all programming, expression-based programming for better code. Let's go with that. Hi. The problem with reorganizing your slides immediately before giving the presentation is you don't necessarily know what order your slides are in. So I don't recommend doing that. My name is Jason Turner. One of the things that I guess I would say I'm known for is I am the host of C++ Weekly, and I've been doing that since March of 2016. So long. Every time I say that out loud, it makes me like a little uncomfortable for how old I am. I've got stickers up here for the YouTube channel if you want any. Yeah, been going for a long time. I also have some best practices books and some puzzle books. I have not brought any of those, and I'm not entirely sure why I didn't bring any for giveaways, because I tend to like to do that. And I forgot, as Patrice was expecting me to give some away today. So now I feel particularly bad about it. He actually said, you'll like Jason's talks. He gives away books. Sorry, I forgot them today. I am a developer, and if you want to check out my stuff, I do have a bunch of open source projects where some of them are truly experimental, and some of them are me trying to actually demonstrate what I see as best practices for C++ specifically. I'm also a Microsoft MVP I just put in my application for my 12th year. So this is what I do. I do training, by the way. This is how I make the majority of my income. And as some of you know, I also give workshops at conferences. Is there anyone who was in my workshop? No. I gave a workshop here this week, and I will be giving a similar workshop again in Norway if you happen to be swinging by Norway in September, or if you're going to be in England in late June by any chance, you can check out my workshop. I also am happy to travel to companies and countries, groups, anywhere. All right, if you want access to any of my stuff, there's a QR code. You can snap it or not. Okay. My talks, I say avoid sitting in the back. I see you. Please interrupt me and ask questions, yell things out. I'll repeat it for the room if necessary, although in this size room, everyone will be able to hear it. So I'm also repeating it for the future viewers of this talk. And this is approximately what my training days look like. I try to make them as interactive as reasonable. Let's say reasonable. Oh, I do have a couple of little prizes, even though I don't have books to give away. My examples are in C++, because that is what I am an expert in. I may as well poll the room. How many of you are C++ specifically programmers? All right, let's do this the other way around. How many of you are not C++ programmers? Connor, do you count? Oh, it's not your primary language. Okay, yeah. All right. These principles should apply to most other programming languages, except for, I would say, functional programming, because you're probably already programming this way if you're programming in functional programming languages. And I will get some clarification from the people who are experts in functional languages. All right. Does anyone have function length coding standards in your projects, on your teams, in your organization? Do you have a hard limit? Do you have a hard limit? What is it?
Generally, it's got to fit on one screen.
Fit on one screen. That's easy. Minus, 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 minus. Do you have a hard limit? 80. Okay. Does anyone else have a hard limit on function line length? For the committee?
Oh, yeah.
I don't think it works that way.
No, like, what's something that would actually change our program?
Yeah.
Like, let's just not compile things that are, and start out moving along.
Okay. Okay, so the comment was that there has been a proposal that, and I don't believe it was actually seriously made as a proposal, that the C++ standards say we refuse to compile functions that are longer than X lines. That would be definitely a thing to do. It probably would make the most difference in the language. So you have a hard limit of 80. Is it enforced on CI? Interesting. So no one else has this limit. Fascinating. I have actually worked with teams. I almost pulled the slides in just now. I've worked with teams that do have a hard enforced by CI only with like team approval, not more than 50 lines of code. You want to work on that team, I think, Tony. You do, yeah. Now, if you don't have a function line length limit, do you have a cyclomatic complexity limit by any chance? Anyone? You do? What does it look like? Whatever the default of playing tidy is. I don't know what that is off the top of my head, and I believe it's a relatively recent, in my mind, addition to clang tidy. And clang tidy can also enforce line limit length, I believe, or function size limits, I think, also. And to your comment, I don't, Tony, since I'm like, do I call out people by name or not? Some of the other speakers were calling out everyone by name. You suggested that the compiler doesn't compile a function longer than this. I have actually seen on very large, on old code bases that had like 30,000 line functions that with early versions of Clang could not compile an optimized build. And I did just a little bit of investigation. It turns out that I know people on like several different sides of this who were involved in fixing this problem. And that is, back then, don't quote me, I don't know if it's still true, Clang's optimizer would use geometric memory growth while trying to optimize very large functions. And so you just simply ran out of memory. It didn't matter how much memory you had, right? So the solution was to detect geometric memory growth and disable the optimizer. So just so you know, very, very large functions, they're probably broken really anyhow. All right. Besides the fact that don't even try to turn on -w shadow if you have very large functions, right? Go ahead, try it, those of you who do. All right. We really only have like one person, two people who can talk about this. How's the cyclomatic complexity thing working out for you? Right. Okay. So for the sake of the video, you said there's a few places where you have to disable the linting there because it is agreed by community that this functionality is necessarily complex, I think would be a way to sum that up. All right. And you for the function line limit length, you said you only have portions of the code that enforce that. All right. You'll see where I'm going with this, hopefully, in a minute here. So again, I just reorganized my slides. Not that that's an excuse, but hopefully this all makes sense. Doing an introduction here to return value optimization. I did confirm that this is a thing that is not unique to C++, but I do know how to demonstrate it in C++. I have this function, get data. It has a ret val. I'm initializing it with a vector. Don't let the auto surprise or confuse you there. It would have been exactly the same if I had put the return type as standard vector int. And then I am writing out the address of retval. And then I return retval on line 7. On line 11, I am getting this return value, and then I am writing out the address of that data, that return value. What did you say? Which is on the stack. Yes, they both will be on the stack. Does anyone have any guesses as to what we will see here? So I want to see the same address. That is what I want to see. This is fundamentally return value optimization as far as our ability to look at it through the C++ view. These things both have the same address, and the C++ standard specifically says that when return value optimization can be applied, in the standard it's called copy and move elision. When a copy or move can be elided, it is the two identifiers are treated as the same way of referring to the same object. I think I got the wording mostly right there. So these objects are the same object. retval and data, they're the same object. They look like different objects to you. This thing on line 5, that's not an assignment, that's initialization. And I've got the same object twice, basically. And if you're curious, this thing, I'm going to turn off the optimizer entirely. My slides defaults to 03. I turn off the optimizer, they're still the same object. This is not a function of the optimizer. Any questions about that? I mean, oh, by the way, we can interact with any of my slides that we want to. Thank you. Oh, y'all need more coffee. All right. Any comments? Any questions? Okay. That was named what we at least colloquially call named return value optimization. NRVO, RVO, copy elimination, move elimination, elision, these things, they're related terms. So the thing on line 4, this is guaranteed and required in C++. I must have move elision here. It must have return value optimization. The thing on lines 9 and 10 is not required. But I will say, so notice my, my wording here, because I couldn't come up with a good way to say it, 100% likely. I did actually go back and test C++ compilers back to 1998 in like DOS simulators and stuff, right? And yeah, they all do this return value optimization regardless of optimization level in this case, but this is not guaranteed, just so you know. We'll get into that in a moment here. But again, stop me if you've got any questions, comments, pictures. Do you need me to pose with the slide while you take the picture? All right. So with return value optimization and named return value optimization, copy and move elision, these things are not dependent on the optimization level. They fall out of how the calling conventions work at the machine level and our ABIs, our application binary interface. Hey, don't go too fast. All right. Tail call elimination, tail call optimization. I don't know, does anyone have an opinion whether you prefer calling this tail call optimization or tail call elimination? You prefer optimization? You what? Unruly. Unrolling. Well, I'll show you another example where you won't think of it that way. All right, this is the ability for the compiler / runtime, if it's an interpreted language, to sometimes eliminate a function call or recursion, resulting in optimizations and reducing or eliminated stack overflow possibilities. So this thing, I added the definition, but this slide here, if you saw this code, if you're like, buddy, what are you doing writing a recursive loop just to sum a range of integers? That's what this is doing. This is objectively a terrible plan, right? Patrice, they're not interacting with me enough. I know, and you can't talk. All right. A student demonstrating how recursion works. Okay, I like the comment. So you're all are experienced programmers. Then you at least know that why would I have the slide up here with the clickbaity question if it was like a straightforward answer, right? So who wants to step through every line of this assembly code? No, actually, I seriously look at this just now this morning, and I'm like, GCC, come on now. I know you did the tail call elimination here, but you didn't need to do partial loop unrolling with like vectorization of the ads. This is probably unnecessary. I can scroll through this code, and what we can see is that a call to sum is completely missing. The compiler was able to transform this recursion into a loop. And if you program in a pure functional programming language like Lisp or something, tail call elimination is absolutely required for the language to work, basically. Otherwise, you couldn't traverse a list more than a few elements deep. Yeah. Yeah. Okay, so the comment was kind of weird that the compiler could do it because I do have a state that I'm moving forward instead of just pure tail call here. Yeah, you know what? I don't know the exact rules for. That is true. All recursion can be replaced with a loop. It's not promised. I'm going to pull down the optimization level one notch and see, without all the ridiculous partial loop unrolling and everything that it did. I know that all of you came here for a 9 a.m. talk to look at a bunch of assembly. And you can just like, okay, it literally tests to see if it's zero. If it's zero, it jumps to L1, which means it's just going to return zero. If it isn't zero, then it is just going to add the values until it hits zero, and then it's going to return what value is left in EAX when it was done. So yes, it did just convert it to a loop. And it's probably not worth spending the time on. But if you squint and stare at this real quick, you might be able to see that Clang changed it to the closed form of the loop. So it doesn't have a loop at all anymore. It just, oh, what the heck is that called? Yeah, so this is a known optimization, but I don't want us to spend too much time on this, but I also don't want us to assume that Clang said, oh, I see exactly what you're trying to do there. I'm going to apply the known optimization. You can do other random things in here, and Clang will still convert this code to the closed form version of the, oh no, now it says, okay, fine, make a liar out of me. Why, Clang, why? Well, anyhow, I can do other things, possibly, and it can do also still generate a closed form version of it. You know what? You used to do that. All right, never mind. All right. Yes. No, I'm telling you that Clang has done a very good job of converting many of these things into the closed forms before. I just, It's a funny thing about regularly putting assembly on your slides like this and trusting the optimizer to do what you expect it to do, because with every version of every compiler, the optimizations change, and therefore things don't always go how I expect them to. All right, let's move. All right. So this is another example of tail call elimination, by the way, which is why I didn't want us to just think about it in the form of recursion. This is a f calls g, and notice that it's not doing a call instruction here. It is not taking up stack space. It just says, wait a minute, the parameters that I'm passing to g are the same parameters that I got. The return value that I need is the same return value that g is going to get, so I can just jump straight to g, and I don't even have to do anything about myself at all. Okay, we need to get to the meat of this. Like I said, this is going to be 5 minutes or 5 hours, depending on how things go. Do you all have time? Okay, so these things are dependent on the tool chain. Now, note my point about return value optimization is that that is not dependent on your compiler flags. That's just going to work or not work. Tail call elimination, tail call optimization, these things are dependent on the compiler flags, the programming language, what optimizations you have set. You might have pragmas that enforce tail call elimination. I believe Plang has an experimental pragma for that, by the way, or whatever you call it. Not a pragma attribute for it. All right. So expressions versus statement. An expression in computers, this is the Wikipedia stolen definitions. In computer science, an expression is a syntactic entity in a programming language that may be evaluated to determine its value of a specific semantic type. That's a lot of words. Statement. In computer programming, a statement is a syntactic unit of an imperative programming language that expresses some action to be carried out. The TLDR here is expressions generate values, statements express intent. Okay, which of these two? Just these two? Yes, I know you probably have a different preferred version. Which of these two do you prefer? Pretend like you're at the optometrist. Do you want option A or option B? Option A or option B? Who, of these options, who prefers option A? Who prefers option B? Okay. All right, so I've got, highlighted lines here. No matter what happens in option A, I have to initialize string T with true, I have to initialize string F with false, and then I choose which one of these to return. Now, I will tell you that neither Clang nor GCC can do return value optimization in this particular case, because it basically requires that there be one known thing through the control path that is the return value, and they don't know at compile time which one's the return value. Option B, I have to default construct this thing, which you tend to think of as a no-op, but I will tell you compilers are very bad at optimizing splitting these two things up. So I default initialize a string with no characters in it, and then I choose which assignment I'm doing the assignment operator in both cases, but I'm choosing which value I'm assigning, and then I return the thing, and that thing has return value optimization. The only reason I am going to prefer option A right now is because I know that those are both short strings. And I know that the compiler can probably optimize it better. But neither one of them are great, right? I said we're going to have more examples. Did you mean something like this, Klaus? Okay, so now which of these two do you prefer, option A or option B? Who prefers option A still? I tried to keep the stable thing stable. Now who prefers option B? All right. Just so you know, GCC is my default compiler here. And just FYI, GCC does not know how to perform return value optimization on the second path in this code. WinRVO tells us that it doesn't know how to do that. So this is, we want it to be better, but it still makes us raise a bunch of questions. Clang does know how to perform return value optimization in both control paths and option B. Just for the record, very surprised that GCC still doesn't know how to do that. It should know how to. It is clear that there's only one possible object that might be returned through both control paths, so it should be able to kind of merge this logic in a way that would make sense. I've never looked at the compiler diagnostics to see if it can say why it can't perform return value optimization. And it's pretty recent. It's just, a couple of versions of GCC ago that it even has the NRVO warning to even let us know in this case. And I enabled it in one of my older, larger code bases. And I'm staring at the code and I'm like the things in my pocket, otherwise I would just sit down right here on the stage. I had carefully crafted all of my code, like all of it, all the way through. We'll show an example if we have time, to be RVO friendly. And then I turn on NRVO on GCC now that it exists, and it's showing me all these places where it can't apply return value optimization. I'm like, I don't know how to fix it. All right, use Clang. No, it's not a general answer. Okay, so same deal here. And then this one, I choose which one I'm going to initialize, and I choose which one I'm going to return. I'm going to prefer option B, even though I now have this warning. Personally, I'm going to prefer option B. Okay, now, see, notice I swapped the one that was changing. Option A is updated. What do we know about option A based on the stuff we've already talked about? What's that? It returns a string, but I mean a little bit more in depth than that. It is now guaranteed RVO required by the standard. I am constructing these unnamed objects in the return statement. I know in C++ that I'm going to get RVO here, and I think I can say with a high level of confidence that if your toolchain, whatever language it is, does something like RVO, which most of them do, you're gonna get it with option A, right? With option B, we're still gonna get that warning. Okay, so, I mean, not to lead you in any particular direction or anything, but who chooses option A? Who chooses option B? Okay. That was basically 100%, but I led the audience, I'm for sure. I do have prizes I need to give away, so someone needs to say something brilliant. All right, yeah, so it's basically a single step through this function. Maybe I cheated just a little bit by not having the switch as a step, but basically it's decide and then do with option A. And with option B, I still kind of at least logically have this question of initialize and then return. And as we just saw, GCC doesn't know how to optimize that. Optimize. I don't like the word optimize there. I don't like the word return value optimization because, like I said, it's not dependent on compiler optimization level. So is it an optimization if it happens with optimizations are disabled? A language optimization? An ABI optimization? I don't know. It was optional, but we know they've been doing it since forever. I have like a false memory or something. I can't find it. Someone who's really, really bored, I want you to find this for me. I swear I read an article on Bjarne's website in 2005 that said return value optimization is an obvious thing that all compilers should be doing. I can't find it on his website today. I used the Wayback Machine. I went to 2005. I still couldn't find it. I don't know where this came from. Okay. Now I have two different options. Again, option A, I have a function called toString. It knows how to convert a bool to a string. Option B, does this work in line? It's print. I take a string, and then I assign the string value that I wanted to have, and then I print the string. Who prefers that expensive function call in option A? Who prefers? Do you see what I did there? It's the same number of lines of code per function. It's fewer. Yes, it's fewer lines per function. And you know what? You're laughing, but I actually want you to hold on to that thought for real. All right. Yeah, I can't stay on the stage. Thank you to the camera crew here for. I don't. You know what? When I'm teaching a class, I don't stand on stage the whole time, right? That would be. Well, I don't know. I'm not a university professor. Okay, so let's say this again. Who prefers the function call? Who prefers the not function call? All right. So there's a hint here and how this is going to fall out. Notice how I've numbered the steps as to what happens, right? So in option A, that's step 1. In option A, it constructs in place the object that I will eventually write to output. That's just all it does. That's what it does. That's what it's required to do, in fact. So if I have any optimizations enabled basically at all, that toString function is going to go away, and it's going to construct the thing in place. And again, in any programming language that has anything resembling return value optimization, that's what it does. It's all about constructing the object that you're going to use in the place where you're going to use it. That's what return value optimization does. In option B, I have to do the default initialization, the assignment, and then the reference of that object. I think it is actually fair to call it 3 steps. So this, notice the function definition exists up here, but we can ignore that function definition because that function doesn't actually get called, right? In the body of this thing, that function's not being called. And anything that's got a just-in-time compilation or anything that is like that as well, it's going to eliminate this call to this function. I'm going to make a quick change, and I'm going to make that static. So the function doesn't get emitted if it's not being used, and we can see that the function is, in fact, not being used. I actually haven't spent a ton of time looking at the differences between these two. I think ultimately they end up generating almost the exact same binary. Yeah. They end up generating the exact same binary in this case. Optimizers are amazing. They make my job harder in some ways. Okay. It's the same number of lines of code. Smaller function. All right. This is not the point of this talk, but I just wanted to throw this out here. If you actually have a function that is actually converting a set of known things into strings, like a toString function for booleans or enumerations or something, and you're a C++ programmer, I'm going to strongly encourage you to spell it like this, where you have a constexpr function that returns a string view. This is going to be the most efficient and safest, cleanest thing that you can do in this particular case. These are all known at compile time values, and just like, we're not going to step through this here, but the compiler is able to drastically optimize that. All right. Okay, which of these two do you find yourself preferring at this point? This is an enumeration to string. I have the default, the assign, the return in option A, and then I don't have those things. I just have return statements in option B. This is potentially a lot more to talk about depending on how much time we want to spend here. Give you a second. Who says, I prefer option A? Who says I prefer option B? Well, see, like, my goal was to lead you to preferring option B, but I still didn't expect you all to prefer option B at this point. Because I know some coding standards are going to give you a hard time with option B. Some people are going to say, oh, you don't have a default in B. I don't want you to have a default, right? Because this organization of a switch statement gives me an obvious place as to where to put the error handling cone on line 18. I either intentionally return an unknown value, or I throw an exception, or I have an assert, or I do whatever it is I'm supposed to do in my code. Line 18 becomes the default fall-through case, and then if I need to add val 4, I get an obvious warning. Not all cases are handled. But with the thing in option A, if I add val 4 here, I'm probably not going to get a warning from my tools, because that default case is going to handle val 4, and then you're going to be like, oh yeah, all the values are handled. But that's not what's actually happening. So I'm a huge proponent of option B, and I'm glad to see that you all completely agree with me now. So the takeaway here, and we'll wrap this, we'll have a summary slide, is notice what I'm doing. This is expression-based programming was the topic here. Switch, in most commonly used programming languages, is not an expression. It doesn't return a value. I am treating it as if it's an expression. I am treating switch as if it returns a value. Note, every single case returns. There's no need for break in this world. Just return. All right. My examples are getting slightly wonky here. I have a loop on the left-hand side. I'm trying to find a client. Don't worry about the details of the rest of the code. I think it's pretty readable here. I've got a client struct, and I am looping over the elements of a span of clients. And then if I find the client that I want, I break from the loop on line 18, and then if found, I output the client. Now on the second option, the find function, I call this find function. It returns to me a reference to the client found, and I print it out. Who prefers the loop? Who prefers the find function? Oh, but you still raised your hand? Oh, you didn't. Oh, that was you. Okay, all right. Here's a. You said the find function has a bug. Is that what you said?
Yeah.
What is the bug, Tony? Yes, if it doesn't find anything, this code should generate a warning for most tools saying that you've got a function that does not all control paths return. Yeah, this is buggy code. See, I'm like trying to make really creative examples, and I'm like, oh yeah, I'll definitely do. Like, we can treat for loops as of expressions too. Look at this, and then like I'm typing away, and then I'm looking at my own beast that I just created, and I'm like, this is terrible. It has undefined behavior. And for C++ programmers, just so you know, if you're Program has undefined behavior, the entire world explodes. So we don't want that. So this is not a great use case. In this case, I'm going to prefer option A, or loop option, because it works. We'll do better, though. I have updated my find function to now be a recursive function. It recurses, and if it finds it, it prints it. If it doesn't do anything. It's actually better, and it is, you're going to actually accept this as, well, yeah, it's definitely tail recursion. This is pure tail recursion, yeah. So this is, in anything that is going to do tail call elimination, this is going to do the right thing here, no question. This one doesn't have undefined behavior, but whether or not it actually works with my data set is going to be partially dependent on whether or not I have optimizations on my tools, right? Otherwise, Stack Overflow. All right, so at this point, who prefers the loop version? Who prefers the recursion version? I'm still going to prefer the loop, I think, myself, too. Really, the point of these set of exercises here is to point out the holes in my logic for what I'm trying to teach you, right? I'm going to acknowledge the problems. Okay, so now I've got that recursion version. Oh, my mistake, I accidentally swapped sides. And I've got an algorithm. So this is a ranges algorithm, ranges find if. Connor can tell you exactly how it works. And so I'm just saying find if the last name equals the last name, and then I check to see if this thing was found, then I print it. All right, who prefers the recursion version? I like that recursion version. Who prefers the I'm using an algorithm built into my library? Now, notice that this algorithm, the algorithms in general, I feel like algorithmic things in general, they're by nature kind of expression-based, right? It's a thing that returns a thing. It generates a value. So I've got that. I shouldn't have done that. I switched sides again. Sorry about that. So I've got this lambda algorithm thing, but over here on the right-hand side, I'm going to zoom this just so you can appreciate it. This is using the find algorithm, and I'm saying find clients with the value last name looking for, like I'm giving it a pointer to the last name member. That's super clean. I really like that personally. If you can use ranges in your C++ code or whatever the moral equivalent is, this is great. I'm a big fan of this. It does exactly what I asked it to do. I have not benchmarked it. You know what? I have not. The simple ranges tend to go away with optimization. The simple range stuff, I'm double down on this. The simple range stuff tends to go with optimization. By the time you've piped a bunch of filters together, it's less and less likely that the optimizer is going to make it go away. My hunch would be that these two things are nearly identical, and we can maybe just do a very high-level look, and just what we're just going to say is, do they generate the same size binary? My hunch was correct. These things do, in fact, appear to be identical between the lambda version and the projection version. Oops. And just for the fun of it, I'll pull up the recursion version. The recursion version is definitely generating different code, and the naive. You know, if instruction count, it was a perfect measure of performance here, we would see that we would think that the for loop is the worst, the recursion is next best, and the algorithms are the bestest. Bestest? What about the one with undefined behavior? That's the real question. Doesn't matter, doesn't work. Okay. So at their cores, most languages, I would say, are imperative languages. Most languages used in industry are imperative languages at their core. We call them object-oriented, whatever, but I think it's fair to say that they're at their core imperative. For, if, do, while, switch, these things are statements. So many of the examples that we walked through showed treating statements as expression. I already said this. We avoid copies and assignments. We rely on tail call elimination. We rely on RVO. So this is the switch expression. I think we spent enough time like looking at this. It's again, I'm just saying, I'm going to treat the switch as an expression. Every possible control flow through it returns. I'm going to treat an if as an expression. Every single possible control flow through it returns. This is what I am proposing to you. Now I have to remember what the slide is about. No laughing at me. Like I said, this should be fine, right? Let's see. So I have a for each, and I loop all the things, and for each element, I call the predicate So my theory here was, notice this puts for each on line 22. My theory here is how can I generalize the idea of making every for loop into an expression? So in languages that treat for loops as expressions, what they tend to do is that the for expression returns the last value, the last thing, the result of the last operation that occurred in the for loop. So I'm saying, here's my for loop. It's for each. I pass it make data, and then I use data. And so then I loop through all of the elements, and then on line 15 here, I return the result of the last predicate executing. So I can generically treat my for loop as an expression. How do you feel about this? Yes, Tony. You don't call it. That's okay. No, I do. Yeah. Last is way more consistent. Yeah, and I had probably typed last, and then I typed the prev, and then yeah. So I loop through everything up before the last one, and then I execute the last one. What about the empty range? Yes, this is again fundamentally broken with undefined behavior in it. Thank you, Klaus. Yes. Do you want a prize? Yeah, it's broken again. So like trying to do this in a generic way, at least in this programming language, does not work well, because if I were to guard for the case where I have an empty range, then I'm right back to where I was, where I have not all control paths are going to return a value again. Oh well. Like I said, I just want to be honest about limitations. Yeah. No, you do not. I'm not even going to repeat that. Yeah. All right, fine. Tony Van Eerd said that that's when you start returning optionals from all of your things, and then you do go down the route of functional programming languages. And that's true, it's what they do. But my problem with optionals in C++ code is that they tend to break return value optimization because we're not very good at initializing them correctly. And then when we receive them, we have to pull that value back out of the thing, which is a second level breaking of my return value optimization. Plus, I have to have an extra switch to determine if the thing returned a thing or not. So I don't like them, and they make me, I want to know why. Why did you give me an optional thing? At least use expected instead if this is your goal. Sorry. You want a prize, Tony? That's true. You didn't find that. Yeah, that's right. You pointed out 2 bugs. All right. So Yeah, I don't know if you're thinking these are strawmen and not practical, and I'm using string for everything. I'm using string for everything because in C++ code, it's a non-trivial thing, so we can actually, if I were to use like ints for everything, it wouldn't matter. The optimizer would literally make it all go away, and it would just return 42 or something, right? Well, yeah, I didn't actually throw the prize to you, did I? You're sitting there like, why don't I have my prize yet? Um, uh, So yeah, we can use vector, whatever. This talk started because of some of the impressive results that I've personally seen from treating switch as an expression. I have taught students to do this, and my students have come back to me and told me that by treating switch specifically as an expression, they have seen drastic code improvements, multiple bugs fixed, huge reduction in lines of code. So I wanted to generalize this. And my generalization is put each statement in a function and treat it like an expression. This is going to make some of you uncomfortable. So this helps us to leverage RVO, gives us a simple, clean separation of concerns. We rely on the compiler to decide what functions to inline or not. Compilers are very good at this thing. It is literally their entire jobs. So I applied it. I applied it in one of my toy projects, but it's a toy project that still does something. If you watch the YouTube channel, you've seen it at some point. It is an infix expression evaluator project. It is called infiz on my GitHub repository. And this was my evaluate stacks function. And so I have a while with a switch. It starts with an if. I have a while with a switch. And the cases each have ifs in them, where they pop off the operands to the expression, and then they evaluate the result, and they push the result back onto the stack. Okay? So it took me a while, but I said, how do I make this better? How do I follow my own rules? You can ask my wife. Well, she's not here. But if she was, you could ask her about how I would just be randomly wandering into the kitchen. Oh, it's not working like I wanted it to, right? So how do I rearrange this? So the level 1 rearrange is I've got this take binary parameters, and this abstracts out the logic of popping operand 2 first, operand 1 first. If they both have a result, then I return a pair of these things. If they don't have a value, then I return an unexpected. This is all expected-based code right here. So more like Tony was suggesting, actually, even though I gave him a hard time. And then I've got this evaluate binary, and I can say, okay, I take the binary params, and then I apply the operation to them. So now my while has still a switch in it, and I get the binary params, and this is the part of like expected and optional that I personally really don't like, where I get the result, and I have to check to see if the result actually was a thing, and if it was a thing, then I have to, right, do this logic. So this is just phase 1. And this is where I kind of got stuck for a little bit, but I can see that it's making my while loop and my switch a little bit better. But it took me a while brainstorming to figure out how to pull the switch out entirely. So the final result is still that take binary params, but it's got a little bit more logic in it. But notice, every single control path here is in fact a return statement. So if the operation had a top level value, then, or if it didn't, then I return unexpected. I grab each operand as expected, as I want, then I return the pair. And then I have my evaluate binary, and I take those parameters, assuming the parameters are, what they're supposed to be, then I actually process the operation on them. And again, this is all expected-based logic. This would actually be considerably cleaner if it was using exceptions. I'll just say that. Exceptions actually help you write really straightforward code. I know people don't like them. It's cool to not like exceptions. And then my evaluate stack, I did end up with a helper lambda here. And the helper lambda handles my binary operation. So now I actually have it. My switch statement is now basically in its own function with just a tiny helper. So I say if I've got the plus sign, handle plus, minus, multiplies, divides, and I've deduplicated a bunch of logic, then my evaluate stacks function, this is the thing that took me a while to get there, but while there are operators left, evaluate the next chunk of numbers and operators. And if there aren't, then return. If something doesn't go right here, then I return an unexpected again. So I did it. And it actually resulted in 25 fewer lines of code overall with the code deduplication. I followed what I would like to think is a good practice for you all to, mull on later. And yeah, I actually like it. I like it way better. I like it way better than this version, where each case statement is itself, 15 lines of code long? I don't think that this is good programming. I mean, it's programming I did. I don't think it's good. I think this is better. All right. My job, by the way, I'll repeatedly say this, is you're not expected to 100% agree with me. Part of my job is to make you uncomfortable and perhaps slightly angry with me. And then I know you're thinking. So effectively, every control statement becomes its own function or lambda. Key point, this is a key point for limiting function sizes. That's why I started by polling you all on this. If you do have function size limitations, you basically have to do this if you want your code to fall within company guidelines. Guaranteed RVO can be effectively leveraged. A break in this world, I think, is completely outlawed. Break is return. All right. And then there's the question of what if my functions return void? What? Void is a code. You know what? I might almost agree with you if I have the next 2 minutes to get to the slide. So just so you know, it is perfectly legal and valid to do this. I can return from a function that returns void from a function returning void. You see what I'm doing here? It's valid. It's weird, but it's valid. And then there's also this question. There is a part of the C++ standard that we used to think of as returning void, but now returns a value. And I will just give you the answer because we're out of time. This is pushback versus emplace back. Pushback from C++ 98 era returns void, and place back returns a reference to the thing that was just added to the container. Logically, pushback should also return a reference, but they can't. They can't because it would break ABI. So that can't change. But every place where they can in the standard, they've done this, and it's because it's for free. If you already have information that you can return to the user, return it to the user. Is that what you're going to say, Tony? Basically? Okay. He's not disagreeing with me terribly. All right. So, yeah, then why does pop back return void? And the answer that I have is because there is no good way to do anything other than return void and pop back. I could theoretically return a reference to the object that was just destroyed. No, don't return an reference to the object that was just destroyed. That's a terrible idea. What's that? I'm not repeating that. All right. I could return a copy of the object that was just destroyed, but that's not something I can do for free. That copy could be expensive, or that move, or whatever would need to happen here. What's that? Okay, that's fair. So Klaus said it's not. There's no way to do it in an exception-safe way to return a copy or a move of the previous value that was just removed. So yeah, so what I'm just acknowledging is that there might be places where you can't. I could be wrong. Happy to be proven wrong. Like I said, I just wanted to acknowledge all this. So don't try too hard to make a function have a return value, but do try to have a function return value. For C++ specifically, keep your be sure to use const expert, keep your types trivial, and we don't have time to look at that, and that's fine, because we covered everything that I cared about covering. That is me. Thank you very much for coming to my talk. It is exactly on time.